Hello everybody. Okay, so please wait for 1 minute. I think there is so much disturbance here, so please wait.
राजकुमार, आज मेरे राजकुमार, राजकुमार, आजा तो आजा भागे भागे
जल्दी जल्दी
आजा
Hanji. So I hope that there is no disturbance now. Everything is clear. Hanji. So I hope that there is no disturbance now. Everything is clear. Disturbance now. Everything is clear. Am I visible, guys? Am I visible? मैं visible हूँ? Am I visible to you? अच्छा Okay, just hold on. एक्चुअली मैंने आपको बताया था कि मेरा जो सेटअप है, जो लैपटॉप है, वो सारा जो है रीसेट हो गया, कुछ प्रॉब्लम आ गई, तो सारी की सारी जो सेटिंग्स हैं वो करनी पड़ रही हैं। एक्चुअली मैंने आपको बताया था कि मेरा एक बार मुझे वॉइस बताओ, वॉइस ठीक है या वॉइस में भी कुछ रिक्वायरमेंट है करने की? वॉइस इज क्लियर टू यू? वॉइस इज क्लियर टू यू गाइस? मैं भी सुन लेता हूँ एक्चुअली, एक बार आप मुझे तो बताइएगा। ठीक है, सुन लेता हूँ। Okay, now I think uh, everything is visible to you, right? Everything is visible to you, correct? चलिए, so थोड़ा सा सेटअप में टाइम लग गया because I already told you that there was some issue in my laptop. Actually, Windows crashed that day, and so I have to set it again from scratch. So chali, let's start our lecture, guys. So okay, now good morning all of you guys. Very good morning, Vishnu, Avijit, Kia, everybody. Good morning all of you. और कौन कौन है लेक्चर में अभी? और कौन है लेक्चर में अभी? चलिए, सो जो भी लेक्चर में है फटाफट से एक बार मैसेज कीजिए. नाउ लेट्स डिस्कस द class today. So previously what we were discussing, guys, previously what we were discussing, so previously we were discussing the centrifugal pump actually, right? So what is the centrifugal pump? It is the hydraulic machine which convert the kinetic energy into the pressure energy. Good morning, Meena. Anushka is there, right? So this is my centrifugal pump. So there are some components in the centrifugal pump: impeller, casing, suction pipe, delivery pipe. We discussed it, right? And we discussed the volute casing, right? In that volute casing, what is the meaning of this increasing diameter? We already discussed this, right? And we discussed the velocity triangle actually, right? So as I told you earlier that you can say that directly there is you will not find any question in the gate from the velocity triangle, right? It's just for understanding that how the things are come, you know, from where the things are coming. So this is the only motto to discuss these things with you, right? So velocity triangle, and in the velocity triangle we discuss the inlet and outlet velocity triangle. So these are the things we discussed actually. Now tell me, is there any issue in the velocity triangle? Is there any issue in the velocity triangle? बताइएगा. Should I repeat it again, or can we move forward? Should I repeat it again or can we move forward, guys? बताइए. Let me know. Let me know. Everything is clear? Repeat. Okay, I will repeat it. Okay. Okay, so first of all, if you have any problem in the velocity triangle, I think there is a problem in the relative velocity, and there is some problem in the relative velocity, I think. So first we need to understand the relative velocity actually. Okay, first we need to understand the relative velocity. So what is the relative velocity? It is nothing but it is basically the, see, a very simple thing here, very simple बताऊं मैं आपको. There is one term that is called speed, and there is one term that is called velocity, right? What is the speed? Speed is the scalar quantity and velocity is the vector quantity. For the addition of scalar, sir, how we know the direction of water? Okay, let me tell you everything, right? From scratch I will tell you everything. Speed is my scalar quantity and vector is my velocity is my vector quantity. For the addition of scalar quantity, there is nothing we have to do work, just simple addition you can apply for the scalar, like 2 plus 3 is equal to 5, like that. 2 minus 3 is equal to minus 1, like that. So these are the basically for the scalar quantity. In the vector quantity, direction is involved, so we cannot directly add, subtract or multiply in like that. So in the vector there is separate method of the addition, there is separate method of subtraction, there is a separation method of multiplication, and there is separation method of division. No, there is no division in the vector quantity. In the multiplication we studied the dot product and the cross product. What about the addition, the subtraction? Relative velocity means the one velocity to the minus the another velocity. That's it, nothing else, right? Like we have a velocity VA and the velocity VB. If I want to calculate the velocity of A with respect to B, what I want to calculate? I want to calculate the velocity of A with respect to B. That formula says velocity of A minus velocity of B. Simple. Like if a vehicle is going in this direction with 5 meters per second and another vehicle is going this side with 4 meters per second. What is the relative velocity of A with respect to B? What is the velocity of A with respect to B? So how you calculate this relative velocity? Very simple. Velocity of A, what is means 5 meters per second. And in the vector quantity directions, we have to put a sign for the direction. This direction I assign positive and this direction I assign negative. So velocity of A is 5 minus velocity of B. Velocity of B is 4. This is the magnitude, but we are dealing with the vector quantity, so we need to put the negative sign here. What it is? It is 5 plus 4 is equal to 9. So this is the relative velocity of A. It means relative velocity of A with respect to B means what? Relative velocity of A with respect to B means you have to keep B at rest and you want to watch the velocity of A. ठीक है, तो अगर दो vehicle, if two trains are crossed each other, then it seems like the velocity of your train is increasing, but actually increase थोड़ी करती है. That is basically relative velocity. At that time you see the relative velocity. So okay, forget about it. If you understand it, then okay. If you don't understand it, don't worry. There is no issue. You have to understand this formula only. So VAB is equal to VA minus VB. What is this? See, what is the difference between the subtraction and the addition in the vector form? Velocity of A with respect to B I got is velocity of A minus velocity of B. Okay. Okay, I am saying that any vector is velocity of A plus velocity of B. if I add this velocity, I am getting this vector, and if I am subtracting these velocity, these vectors, I am getting this velocity. ठीक है? Okay, what is this? This is the addition. This is the addition of the vectors, right? So let's suppose we have a vector. Let's suppose this is my vector A, and this is my vector B. Let's understand this, guys, right? Let's understand this. This is my vector A and this is my vector B, and I want to add these vectors. So as I already told you that these are not the scalar quantity. You don't know, you cannot add these vectors, these two quantities like the scalar quantity, right? Because there is direction involved here. So in the vector form there are two methods. One is the triangle method and another is the parallelogram method. Triangle method says that do one thing, just add this vector head to tail. So I add this vector head to tail, and the resultant vector is basically join the tail of this and head to this. So this is basically your resultant vector. So my resultant vector is equal to A plus B. This is the one method. Second method says that do one thing, add these two vector tail to tail. Add these vector tail to tail. So this is the vector A and this is the vector B. This is the vector B, right? And make the parallelogram. So just replica of this vector shifted here. This is also vector B. And replica of this vector A. This is the vector A. I make the parallelogram of it, right? Now the resultant of these vector is the diagonal of these parallelogram. So this is the basically resultant of this vector. So this is the addition of the two vectors. Sir, why you discuss the addition? We are interested to calculate the relative velocity, and in the relative velocity we require the subtraction, not addition. Why you again and again repeat this? So guys, there is nothing kind of subtraction in the vector quantity. Actually, this is the addition itself. This is the addition itself. So what is the meaning? See, this is my vector A and this is my vector B. This is my vector. Let's suppose this is my vector A and this is my vector B, right? So like this I can get the resultant of it, which is passing between the which is passing through in between the A and B, the resultant of A and B. If I am interested to calculate the A vector minus B vector, it means just do one thing. Add these two vectors in what way? Just change the direction of the B. So this is my plus B. If I write this B vector, so what is this? This is actually minus B vector. I just change the direction of vector B, not the magnitude. I just change the direction. So this direction is positive, then this direction is negative. So basically now I have this A vector and this is my minus B vector actually, right? So if I add these two vectors, what is the name? What is the now I have A plus, I have to add these vectors, ठीक है? ध्यान रखना, मैं इस vectors को add कर रहा हूँ, nothing else. A plus B, and B is actually, this vector is minus B. So what is it? It is A minus B vector. So this is my vector, and the resultant of these vectors is how we calculate. Just you can make the parallelogram of it. There is no issue. So B vector, replica of B vector is this, and this is my A vector, and this is the resultant of it. This is the resultant of it, right? So actually we can say that, so vector A minus B is my R vector. So R vector is my relative in terms of velocity. If this is the VA and this is the VB, then I can say the resultant velocity, relative velocity, is basically, this is the direction, this is the magnitude, this R is my relative velocity, which is equal to velocity of A minus velocity of B. You understood the concept, guys? You understood the concept or not? You understood the relative velocity concept, yes or no? Tell me. You understood the relative velocity concept or not? Let me know. Let me know so that I can move forward. बोलिएगा. ठीक है. So there is nothing kind of subtraction. It just only the addition. You have to do what? Just reverse the direction of one vector and add them. That's it, nothing else. Just reverse the direction of one vector and add them. That is a subtraction itself, nothing else, right? Okay. Now let me tell you about the inlet velocity triangle, right? So simply, this is my absolute velocity. This is my absolute velocity of the water, right? This is my absolute velocity. Means जो water की खुद water jet जो impeller blade पे टकरा रहा है ना, जो impeller blade पे टकरा रहा है, यहाँ से जाएगा water impeller आई से, यहाँ पे जो the water is striking here, that is the velocity v1. So v1 is my absolute velocity of the water, nothing else, right? Okay. Now see, just if you have any doubt in the inlet velocity triangle, don't ask for now. After the end of the topic you can ask, okay? Because there is some thing is there, I will tell you at the last of this topic, तो आपको समझ में आ जाएगा. Don't worry about that, right? But I'll make sure कि अभी आपको कोई doubt ना है. हाँ, if you have any doubt in the outlet velocity triangle, then you can ask here. So this is my velocity. This is my absolute velocity of the water. ठीक है? And so this absolute velocity of the water has two components. Okay, and okay, this is my absolute velocity of water v1, and this is c. Actually, the blades are moving like this. The blades are moving like this, right? So actually, if this is the, you can say the impeller, so this impeller is actually moving like this, right? Because the water, basically we have to hold the water at this blade actually, right? Okay, so this blade is moving like this. If this blade is moving like this, it means the velocity of this tip of the blade having the velocity in this direction, tangential velocity, and the velocity of this point of the blade is this direction. So these are the absolute velocity of the blade. These are the absolute velocity of the blade. Again I am saying blade is not moving like this. Blade तो साथ ही साथ ऐसे घूम रहा है. So both the ends have the velocity in the left direction. So in the right direction, right? So u1 and u2 is what? It is the absolute velocity of the blade. v1 is my absolute velocity of the water. We are interested to calculate the relative velocity because water and blades both are in the motion. So there should be relative motion between them. There should be a relative velocity between them. Simply. Okay. Now guys, this is my v1 and this is my u1. So I just put this u1 here. If you know, I don't know you are aware of it or not. We can shift the vector parallelly. We can shift the vector parallelly. There is no issue. ठीक है? Parallelly हम vector को shift कर सकते हैं plane में without changing its direction, without changing its magnitude. If you are not going to change the magnitude and the direction of any vector, then the vector will be same in a plane. You can move the vector in the plane, right? So this is my vector velocity. This is my vector, which velocity? u1. So I just write this u1 and this is my v1. So this is the relative velocity of these two velocities. So v1 is the relative velocity of these two velocities, right? So v1 has two components. This one horizontal component and the vertical component. So this is actually my vw1. This is my vw1 actually, right? And this is my this is my vertical component. This is the negative. This is the perpendicular side. So v1 has two components, vw1 this is vw1 and this is my vertical vf1. vw1 is the horizontal component of the v1 and vf1 is the vertical component of the v1, that's it. And this is my relative velocity. This is my relative velocity actually, right? ठीक है. Okay, now let's discuss the outlet velocity triangle. ठीक है, अभी inlet velocity triangle में if you understood the components of the v1, very good. If you know the which one is vw and which one is vf1, well and good. If you know the what is the vr1, well and good, right? Now do not ask about the direction of this inlet velocity triangle. I will let you know after the end of this topic. Don't worry about that, right? Now I'm explaining the outlet velocity triangle now. See, so outlet velocity triangle, how to understand it? Okay, this is my outlet velocity triangle. चलो मैं एक फ्रेश पेज पे ही आपको समझाता हूँ. So this was my blade, है ना, इस तरीके से मेरी ब्लेड है. So let's suppose this was the blade tip. Okay, so this is my u2, this is my u2, right? Okay, clear it ना? हाँ जी, बताइए इतना समझ में आ रहा है what I'm trying to say? And this is my velocity v2, this is my velocity v2. So this is my absolute velocity actually, this is my absolute velocity actually, right? Is it clear to you? Now I want to calculate the relative velocities, है ना? I want to calculate the relative velocities. So what you have to do, just reverse the direction of u2, just reverse the direction of u2. So this is my u2, I just reverse the direction. Is it clear to you? Now just now you can make the triangle, sorry, and make the parallelogram of it. Now that this diagonal is basically what? It is basically the, ये थोड़ा सा मैंने अजीब सा बना दिया. This is what? This is my velocity. Which velocity? Relate. पता नहीं यार इसमें क्या अपडेट आ गया है, ये थोड़ा सा टैप होते ही परेशान कर दिया. This is the relative velocity between v2 and u2, right? So this is basically. So in the triangles I need the only sides. So this is my v2, this is my v2, and this is my vr2, this one, right? This is my vr2, right? Okay, and this one, what is this? So this is my actually u2, this is my u2, right? So this is my u2, this one, ये जो मैंने यहाँ पे किया, this one, this is v2, this is vr2, and this one is what? This is my u2. Clear? This triangle is clear. Now we take the components of the v2 like v1. So this is my v2. So this is the horizontal component. Horizontal component is vw2, and this is my vertical component. This is my vf2. बताइए, right? Is it clear to you or not? This is my beta and this is my phi. Tell me that you are getting my point or not. Tell me that you are getting my point or not. How this triangle I made with the help of the relative velocity. Now it's clear? Now it's clear or not? Now it's clear or not, guys? Tell me. Now it's clear or not? जल्दी बोलिए. If you have any doubt, you can ask. पूछ सकते हो अभी भी आप, कोई दिक्कत वाली बात नहीं है. Is there any problem in the outlet velocity triangle? Is there any problem in the outlet velocity triangle? Yes, VR2 is the resultant vector. Yes, VR2 is the resultant vector. VR2 vector is basically V2 vector minus U2 vector. Or you can say this is the resultant vector of V2 plus minus U2. This is my VR2 vector, right? So in addition terms, we can say it is the resultant vector, and in the relative terms, we can say it is the relative velocity between V2 and U2. So it is the relative velocity of the water with respect to the blade. It is the relative velocity of the water with respect to the blade. With respect to blade means if you are sitting on the blade, then the direction of VR2 is same the direction which you will see that water is going like this. Water is going like this, right? Very simple. If you are in the ground floor, अगर आप ground floor से देख रहे हैं, then you will see the water is going like this. And if you are sitting on the blade of the impeller and you are rotating with the blade, then you will see that water is going in this direction. ठीक है? So VR2 is what? VR2 is the velocity of the water with respect to the blade. Velocity of the water with respect to the blade. With respect to the blade, जिसको भी हम बोलते हैं with respect to this, इसका मतलब that will be the observer. With respect to the blade, it means that blade will be the observer, right? Or if we are observer, then we have to sit on the blade and see the things. I hope that this is clear to you. Yeah, Maina, is it clear to you, beta? VR2 is the relative velocity, or you can say it is the resultant vector of the V2 and U2. V2 and minus U2. Okay, VR2 is the resultant vector of the V2 and minus U2, or in other terms we can say it is the relative velocity of V2 and U2. Or what is the physical meaning? That if we are sitting on the blade, then VR2 direction is that direction by that direction which we will see actually that water is going like this. And if we are observing this with from the ground frame, then we will see the V2 is the velocity of the water, because this is the absolute velocity of the water, right? ठीक है, is it clear to you? Velocity triangle I hope सबको clear है. जो भी यहाँ पे जो भी यहाँ पे हैं बताइए मुझे that velocity triangle is clear to you or not. If you have any problem अभी भी तो you can ask guys, है ना? ठीक है. Now see what we were studying. Okay, derivation is clear to you. जो अभी तक हमने किया था, whatever we discussed that time, that is clear to you, or we need to discuss it again, Okay, so these are the things, है ना? ठीक है. चलिए, I will repeat it again. थोड़ा फास्ट में रिपीट कर देता हूँ. See, so work done by the impeller on water. We want to calculate the work done by the impeller on the water, because ultimately impeller is moving and the impeller giving the energy to the water. Just understand it, right? Impeller is added some energy to the water so that water will delivered up to a certain height. Okay, so first of all we write the mass flow rate which is coming in to the impeller. So this is the mass flow rate which is coming into the impeller. Mass flow rate is simply rho AV. So which A is the area of that impeller and rho is the density of the water. V1 is the velocity of the water by which it is coming into the impeller. So V1 is my velocity by which my water is coming to the impeller. So my rho AV1 is the mass flow rate which is coming in. So this is my mass flow rate coming in. Mass flow rate coming in impeller. Okay, now we want to calculate the momentum transfer, or you can say rate of the momentum actually. So rate of the momentum, it means the mass flow rate multiplied by the velocity. Okay, so we write this momentum rate in the x direction. So we need to, so what is the momentum here? Simple si baat. What is the momentum? Mass into velocity. What is the velocity? This is the direction of the velocity is same in which direction? On the direction on which you want to calculate the momentum. That's it. If you balancing the momentum or if you writing the momentum in the x direction, so you have to take the velocity in the x direction. If you are writing the momentum equation in the y direction, so you have to take the velocity in the y direction. That's it. If you are talking about the rate, so just instead of mass, take the mass flow rate. That's it. Okay. So momentum at inlet in the x direction is what? Mass flow rate multiplied by the velocity. Which velocity? In the x direction. So this is my mass flow rate, and velocity in the x direction is VW1. So VW1 is the horizontal component. This is the horizontal component of V1, right? Okay. Now what is the angular momentum? What is the rate of angular momentum? It is a d upon dt. This is the basically rate, and MVR is my angular momentum, right? Okay. So now what is this is my angular momentum. So angular momentum, rate of the angular momentum at inlet क्या हो जाएगा? It is my rho AV1. So it is my actually M. This is actually my M, right? Or you can say M dot VR. So VW1 into R1. Clear? At the outlet per second is my rho AV1 into, this is my M dot, and this is V into this is R. So this is my M dot V. At the outlet, what is the velocity of the V2 in the horizontal direction? That is the VW2. That is VW2, right? VW2. I hope that this is clear to you, right? समझ में आ रही मेरी बात नहीं? Okay. And R2. Why I put the negative sign? If you see the direction of the W2, then that is the opposite to the VW1. So this is my V2. If the direction of V2 is this, then this is the vertical component and this is the horizontal component. So this is the direction. VW1 direction is in this direction, so that is the positive, and the direction of VW2 is this in this direction. So you have to put the negative sign for it. We have to put the negative sign for it, right? So the rate of momentum is basically this. Now, as you know that in the linear parameter, what is my force? Force is my rate of change of momentum. And if things are moving, then instead of force we define torque, and instead of linear momentum we define angular momentum. So likewise I can say my tau is what? Tau is my change in angular momentum per second, or you can say the rate of the momentum transfer, right? So tau is equal to my what? Change in the momentum transfer per second. I just minus these two equations. Then I will get rho AV in common, VW1 R1 plus VW2 R2. Okay, so what is it? What is my work done per second? Work done per second is my force multiplied by the velocity actually, right? Okay, so but we are dealing with the moving things. So for that purpose, instead of force we define torque, instead of linear velocity we define angular velocity. So work done per unit time is equal to torque multiplied by the angular velocity. So torque I already calculated, and I just multiply with omega to the whole equation. Again, so this is my rho AV1 divided by, this is my VW1 and this is my U1 actually, right? U1 is my linear velocity of the blade, that is the angular velocity multiplied by the radius R1. Similarly VW2, and this is my U2, right? Is it clear to you guys? यहाँ तक सबको clear है? Is it clear to you? सबको? Everybody? Everybody? So this is basically my what? This is basically my work done per second. This is basically what? It is my work done per second. What? It is my rho AV1 into VW1 U1 plus VW2 U2. Right? If I define this term with this is the work done per unit second. किसका work done है ये? That is the work done of the impeller. This is the work done of the impeller. if I'm interested to calculate work done per unit second of the or per unit of the weight of the fluid striking per second. Work done per second, what is it? It is the impeller work done per second, कि एक सेकंड में impeller कितना काम कर रहा है. In 1 second, how much impeller do its work on the fluid, or you can say if it is water, on the water. Now I'm defining work done per second per weight of the fluid. That per second, if the fluid is striking per second, the weight of the fluid which is striking per second, on that weight of the fluid, how much impeller is working, how much impeller is doing work. So that is basically rho A V1 into V W1 U1 plus V W2 EU2. So that is the work done per second divided by, we have to divide with the weight of the fluid per second. So weight of the fluid means m dot into G. So m dot is equal to rho AV1 into G. Is it clear to you guys? So rho AV1 gets cancelled out to each other, and what is it? This quantity is my 1 upon G into VW1 U1 plus VW2 U2. ठीक है? Is it clear to you? Is it clear to you guys? बोलिए. Is it clear to you? So actually this equation is valid. This is the actually general equation, guys. This equation is actually general equation, and we modify this equation in the for the case of the pump. Okay? For the case of the pump, basically we write this equation. We redefine this equation. We refine this equation. What is it, right? Okay. So now just understand it. If we are talking about the centrifugal pump, then for the centrifugal pump there are two things. First thing is that this alpha is actually 90 degree, guys. What is this alpha? Alpha is basically 90 degree. So what is the meaning of 90 degree? It means that my V1 is actually striking the blade perpendicularly. And I hope that you remember that animation in which you just remember that water is perpendicularly striking to the blade. Okay? So this alpha is actually my 90 degree. This, whatever we write the velocity triangle, this is in the general term. These velocity triangles, same velocity triangle will be formed for the turbine also, and it is it is also written for the any blade which is moving with some speed, right? And from case to case we define, we generalize, we just modify our equation with the help of the generalized equation, right? So first thing is my alpha is equal to 90 degree. So मैं आप पूछ रहे थे ना कि ये velocity direction मुझे कहाँ से पता लग रही है? So ये इस यहाँ से पता लग रही है. मुझे पता है, I know that in the centrifugal pump my absolute velocity, my water will strike the perpendicular to the blade, right? Is it clear to you? So if you know this, that if V1 is my only perpendicular this, if my V1 is perpendicular, then I can say that the horizontal component of the water is 0. VW1 is 0, yes or no? If my alpha, agar hai hi perpendicular, if there is some perpendicular, so this perpendicular has no component in the horizontal direction. Horizontal direction में इसका component थोड़ी होगा, yes or no? If something is in the horizontal, it means there is no component of this horizontal in the vertical. If there is some vertical, then there is no component in the horizontal. These are the basic of vectors here. If there is some slanted or you can say any vector, so this slanted has some component in the x and in the y. But if it is in the y, then there is no component in the x, and if it's totally in the x, then there is no component in the y. So for the centrifugal pump, this alpha is equal to actually my 90 degree. So in that case, this is my Vf1 is equal to my V1. Vf1 is equal to my V1, right? So first thing is that. Second is that in the centrifugal pump, my beta, this is my beta na, my beta is actually greater than 90 degree. ठीक है, so here we just यहाँ पे जो मैंने लिखा है that is the less than 90 degree, but my beta is my greater than the 90 degree, right? So these are the manipulation for the centrifugal pump. So for centrifugal pump, my beta is greater than 90 degree. So if my beta is greater than 90 degree, then this equation is actually written as 1 by G and VW2U2 minus VW1U1. And again, and my alpha is basically 90 degree. If my alpha is 90 degree, then there is no horizontal component of the V1. It means this component is also 0. So what term we have? We have the VW2U2 divided by G. This is the term we have. This is the term left here. This is the term actually left here. बोलिए. You understood it? Understood my point? Yes or no? Tell me, guys. Understood my point? बोलिए, yes or no? Get my point or not? So what is it? It is my work done per second. What is the meaning of work done per second? Work done per second simply means power. Work done per second is what? Work done per second is simply my power. Okay, power divided by weight of the fluid striking per second. Weight of the fluid striking per second. So I can write this weight of the fluid striking per second is W into Q, right? W is my specific weight, means it is rho G multiplied by the discharge. What is it? It is my Newton per second. It is my Newton per second, right? Is it clear to you? So W is my weight of the fluid striking per second. P divided by WQ. That is equal to, I am getting VW2U2 over G. हाँ जी, हाँ भाई, कोई प्रॉब्लम है तो आप पूछो. ऐसे आराम से बैठ के देखने से कुछ नहीं होगा. You are either you are getting my point or you are not getting my point. That's it. Either you are getting my point or either you are not getting my point. Tell me, you are getting my point or not? हाँ जी, बोलिए. Is it clear to you? Is it clear to you?
कैसे लिए थे? मुझे भी नहीं था कैसे.
So VW2U2 over G is basically work done by the impeller on the water per second, per unit of the water. ठीक है? Clear? So actually we can understand this point also further if we define this. What is this P? This is the P which is we are getting. This is the P actually we are getting from the impeller. right? This is the power which I'm getting from the impeller, or you can say this is the power which is basically or you can say this is the energy supplied to the fluid by the impeller, right? This is basically this is basically in terms of the head, and this is basically your H, right? This is your H, this is your head actually, this is your actually head, right? So this is called your ideal head. Okay, this is called your ideal head. So here I can write this is my P is equal to WQH. This is my actually head. This is actually my head. Okay, now let's understand the other things. यहाँ तक सबको समझ में आया ना? धीरे धीरे I will let you know everything. ठीक है, it may be possible that कि अभी थोड़ा सा कुछ चीजें आपके दिमाग में कुछ डाउट के रूप में हो, but I will let you know. A we write is area of the wheel or the cross section area of the pipe. No, not the cross section of the pipe and not the cross section of the wheel. Wheel का area नहीं है. That area is basically what? See, that area is basically the impeller area, because in that area area कौन सा लेंगे जिसके अंदर water flow हो रहा है actually, right? So what what area water is actually flowing, and you don't need to calculate the area actually. ठीक है, you don't need this. ये इस area में से आपका water जो है ना वो move out हो रहा है. तो जिस area में से water discharge हो रहा है that area basically you have to take. ठीक है, but there is no need to calculation of this area, है ना? Ultimately वो area देखो यहाँ से cancel out ही हो गया ना. एरिया जो है वो ऑटोमेटिकली कैलकुलेशन में से गायब हो गया आपका. So there is no need to calculate that area, but yeah, what is the A? What we will take area, rho AV, mass flow rate in. So area we have to take in the area in which the mass is flowing actually, है ना? If we are taking the wheel area, it means we are taking the area of we are including the area occupying by the blade also. ठीक है, clear? Is it clear to you? लिखा सबने इतना सबने लिखा? Okay. Now heading heads. Okay, now different types of head we will discuss. Okay, so just try to understand it. We define a manometric head. Manometric head is nothing but it is basically the head which you calculate there. What is that head? It is my V2 VW2 U2 divided by G. I call it as an ideal head. I call it as a ideal head. Huh? The head which is required actually. The head which is required actually. But this head do not consider the pump losses, and there will be some pump losses. So in this ideal head, if I minus the pump losses, then I'm getting the manometric head. Is it clear to you? Is it clear to you? ठीक है? Clear? Okay. Just understand it. Let's suppose this is my pipe, this is my pump, and this is the ground, or you can say any reservoir from which I want to lift up the water. So this is the pipe, goes into the pump, and this is the delivery pipe. This is the delivery pipe. Okay, is it clear to you guys? Now see, just try to understand it, guys. What are the different types of head is possible in this case? What are the different types of the head is possible in this case? So you can apply the Bernoulli itself, there is no issue, and also we can define these heads in the different way. Kaise? Simple. So this is my suction side. So suction side has some heads are there, and this is my delivery side. So in the suction side, what possible heads are there? Let's suppose I'm saying that both the tanks are open to atmosphere. Right? Now what heads are possible in the suction side? So first I'm getting this length of the pipe, the vertical length of the pipe. Let's suppose it is my HS. Right? HS is what? HS is my length of the vertical length of the suction pipe. Is it clear to you that this amount of head, this amount of height we have to pump up the water, right? So HS is my what? Vertical height of suction pipe. Okay. Another HF. HF is what? There is some friction losses are there. So this suction pipe, this total is my length of this is my friction loss. Right? Okay. So there is a very important point in this. When you are writing the HS, take only the vertical height of the suction pipe. Means only this height. There is nothing lena dena of this horizontal pipe. Right? Is it clear to you? Because we have to lift up the water. So water को lift करने के लिए, fluid को lift करने के लिए जो vertical head है ना, इसको surpass करना पड़ेगा. So this is the head required actually. While we calculating the friction loss, you have to calculate the total. You have to take the total length of the pipe, because it is the friction loss, and friction loss is basically depend upon the length of the pipe. So in the HF, in the friction loss, that FLV square wala formula, in that you have to put the total length of the pipe. There is a common, you can say, the confusion in this. Most of the teacher, बहुत सारे लोग भी आपको इसको बताएंगे कि vertical height ही लेनी है HF में भी, क्योंकि बहुत certain सा confusion है. So just stick with your fundamental. Friction loss means the loss which is due to the friction. Friction means जितना पानी को length cover करनी पड़ेगी, उतने friction loss उसको face करने पड़ेंगे. So we have to take the total length in the friction loss. That's it, nothing else. Okay. Third one is my kinetic losses. That is my at the entry. Let's suppose it my VI square divided by 2G. This is the kinetic loss. This is my kinetic loss, right? Okay, but guys, most of the time, the diameter of the suction pipe will be larger. So this will be in most of the time 0. ये आपको 0 मिलेगा, ये आपको क्या मिलेगा? 0 मिलेगा. Is it clear to you? So at suction side you will find the head is basically HS plus HFS. At the section is FS. So this is the basically suction side head. So this is the suction side head. Okay. Now what is the head in the delivery side? In the delivery side, first is my HD, simple, the vertical height of the delivery pipe. Vertical height of delivery pipe. Second is my the friction head loss, friction loss, right? And if there is any velocity in it, then it is, let's suppose it is Vd, then it is my kinetic loss, that is my Vd square over 2g. So guys, it may be possible that we have some Vd value, so in that case we have to mention the Vd, this loss. This is my kinetic loss. So this is my HD actually. This is my HD, the head at the delivery side, which is my HD plus HFD plus VD square over 2G. Is it clear to you? So the what about the total head? Actually, this is my total head. Capital H is equal to the head at the suction side plus head at the delivery side. What is this head? This is my HS plus my HFS plus my HD plus HFD plus VD square divided by 2G. So this is actually the total head. This is the actually total head in the case of our pump. Is it clear to you? Okay. So as you can see here that this total head considering all the losses. Okay. This is the total head actually after considering all the losses. So we can say this is my manometric head. What is the definition of the manometric head? Definition of the manometric head is what? It is simply what? It is simply the ideal head minus the pump losses. After subtracting the pump losses, whatever head we have available, that is the manometric head, right? So the addition of all these losses are what? This is the total actual head, which is my manometric head. This is my manometric head. Is it clear to you? This is clear to you, yes or no? Done? Okay, so this is the one way to calculate the manometric head. This is the one way to calculate the manometric head. Second way is HM is addition of all the heads, HS plus HFS plus HD plus HFD plus VD square over 2G. You are getting my point or not, guys? If you have any problem, you can ask. There is third way. Just you do one thing. Just apply the Bernoulli equation at the suction and at the delivery. Okay? At the suction and at the delivery, or at the suction point and at the delivery point, just write the beta, H and HM are the same. H and HM is the same. ठीक है? ये तो मैंने बोला. The total head, watch it. Here this is the HS value, this is the HD value. This is my manometric head actually. ठीक है? What is the third way? Just apply the, you can apply the Bernoulli equation at the suction and at the delivery. So I can write it as P1 divided by rho G plus V1 square over 2G plus Z1 is equal to P2 over rho G plus V2 square over 2G plus Z2 plus, as you know that in the Bernoulli equation we add the heads in the right hand side. All the minor heads, all the major heads, whatever heads are there, we write in the right side. So let's suppose that is my total head available. What is the total? What is this? This is the total head available after considering all the losses. So what is my HM actually? My HM is P1 divided by rho g plus V1 square over 2g plus Z1 minus P2 over rho g plus V2 square over 2g plus Z2. This is the third way. This is the third way to define the manometric head. This is the third way. Right? I hope that this is clear to you guys. I hope that this is clear to you. ठीक है? क्या ये सबको क्लियर है? क्या ये सबको क्लियर है? Is it clear to you? Just understand it, and I think with the help of one question we can solve our complete doubts. जो भी doubts होंगे आपके वो after the manometric head is head loss. Okay, just hold on, I will tell you. It is my P2 over rho g plus P1 over rho g V1 square over 2g plus Z1 minus P2 over rho g plus P2 square over 2g plus Z2. And this is the case. Okay. Okay, I will tell you guys. I will tell you. पहले ये बताओ कि ये तीनों मेथड आपको समझ में है. नाउ आई विल टेल यू द रेलेवेंस ऑफ द मैनोमेट्रिक हेड. नाउ आई विल टेल यू द रेलेवेंस ऑफ द मैनोमेट्रिक हेड. आई होप कि कैलकुलेशन समझ में आई. कैलकुलेशन समझ में आई. कैलकुलेशन समझ में आई. Now see, actually what is the manometric head? Now just try to understand it. What do you mean by the head? What do you mean by the head actually? ये एक important point है. What do you mean by the head? Head is nothing but head is simply the energy required. Energy required. And if we converting that energy in terms of head, it means that is easy to understand that in the terms of length. In terms of the length. Clear? Is it clear to? जैसे कि V1 square over 2g. ये V1 square over 2g. So this is the kinetic head. I convert this kinetic head from the kinetic energy. ठीक है? So that kinetic energy value we required to pump up a liquid. So P1 over rho g plus V1 square over 2g plus Z1. What is this? These are the additions of three energy in terms of head. Pressure energy, kinetic energy and potential energy. And these are in the terms of head. Head means कि इतने मीटर पानी को now we are not talking in terms of energy. We are talking in terms of the length. कि मुझे कितना ऊपर पानी पहुंचाना है. मुझे कितना ऊपर how much length I have to pump up the water. So not talking in terms of energy, instead of it we are talking about in the head, in the meter, that this much meter we have to lift up the water. This much meter we have to lift up the water. Actually at the back end it is in terms of energy. Okay. So VW to U2 over G is my ideal head. This is the actually head. What is it now? What is it now? So this is the head which is applied by the impeller on the fluid. This is the head applied by the impeller on the fluid actually. So हमें करना क्या है? Basically pump have to add the energy to the fluid so that fluid will pump up and reach to the delivery section. Again I'm saying what I'm saying, that ultimately pump have to add the energy so that my water will lift up from the suction point to the delivery point, right? Okay, so pump have to add up the energy. Clear है? So pump को कितना energy लगाना पड़ेगा? How much energy pump have to apply on the liquid so that it can reach the water to the delivery section? Is it clear to you? Okay, so that amount is VW to U2 over G. This is in the terms of head, right? But this head is actually ideal head. This calculation does not involve the losses, but there are some losses there. लॉसेस भी तो ये तो आइडियल हेड हो गया कि इतना हेड रिक्वायर्ड है, इतनी एनर्जी वाटर को, इतनी एनर्जी पंप को रिक्वायर्ड है टू लिफ्ट अप द वाटर. इज इट क्लियर टू यू? Is it clear to you? But we have to, for the real calculation of the head, we have to basically minus the pump losses. Now again, see, इसको छोड़ो अभी. क्या सवाल किसे सोल्व होंगे? ये जो फॉर्मूला है, नंबर 2 फॉर्मूला, HM is equal to HS plus HF plus HD plus HFD plus VD square over 2G. This is my actual formula which we will use in the questions. Now this much head we required to pump up to lift up a water from suction to the delivery pipe. So these are heads are in terms of meter. If I'm saying from the energy point of view, then I can say this much energy, HS plus HF plus HD plus HFD plus VD square over 2G. This much energy pump is required to lift up the water from suction to the delivery pipe. In terms of the head, this is the in terms of the head. So these heads are basically the energy, but the unit of this is the meters. That's why we called it in the head terms, that this much of meter be required to lift up the water. So HM is the basically head developed by the pumps. This is the head required. और अगर मुझे वाटर को लिफ्ट अप करना है, डिलीवरी सेक्शन तक पहुंचाना है, so this much head has to be developed by the pump. This much head has to be developed by the pump. Then only my water will lift up and can reach up to the delivery section. Guys, is it clear or not? You can tell me. बता दो मुझे फटाक से. ठीक है? I can write it as that it is the head developed by the pump. Head developed by the pump is total energy per unit weight. If you are doing this total energy per unit weight, then you will get the unit meter, right? Total energy per unit weight that pump adds to the fluid to move it. अरे जल्दी बोलो, समझ में आ रहा है कि नहीं? महीना कौन कौन ऑनलाइन है, फटाक से बताओ मुझे. To move it from suction side to delivery side. So this is the head actually developed by the pump. Or what is it? It is a total energy per unit that pump adds to the fluid so that it move from suction pipe to the delivery pipe. इस डेफिनेशन से मुझे लग रहा है कि काफी चीजें समझ में आ गई होंगी. ठीक है? इस चीज से आपको काफी चीजें समझ में आ गई होंगी. ओके? क्लियर? राइट? So actually, in simple words, we can say this much energy pump has to apply to lift up that water. ठीक है? And deliver to the delivery section. ठीक है? Is it clear to you? Is it clear to you guys? Now you will understand everything. Don't worry about that, right? Don't worry about that. So at the suction side, these are the mainly heads. This is my vertical height of the suction pipe, frictional loss, and at the delivery section, these can be the three heads, right? And in you can say the many cases your VD square over 2G also 0. ठीक है, ये भी आपको 0 मिल जाएगा. So you have to add only this HD plus HFD, don't worry. ठीक है, वो आपको सवाल में देके you can have that idea that when I take the VD square over TG or when I don't have to take the kinetic loss actually, right? Okay. So I hope that this is clear to you. Now just let's understand the efficiencies in the pump. Let's understand the efficiencies in the centrifugal pump, right? So to understand this, just take the simple idea of it, guys. Just understand it. This is actually motor. This is actually motor. A motor has a shaft. Motor has a shaft. This shaft is actually connected to the impeller. This shaft is actually connected to the impeller. Right? Yes or no? And this is the, let's suppose, impeller. And this is your delivery pipe. Okay? And fluid is coming like this. Fluid is coming like this. This is my suction pipe, and fluid is coming like this. This is my fluid. So what phenomena are happening here? Basically, motor is running. So we are giving some electrical power to the motor. Now this shaft had some power. Okay. But do not assume, we cannot say that the same power is basically applied to the impeller. Okay. Clear or not? There is some shaft power, and we cannot say that the total power. Simple सी बात है, एक बात बताओ मुझे, एक चीज बताइएगा मुझे, सिंपल सी. Is it possible that whatever we apply the electric power to it, that electric power is 100% convert in the shaft power, or you can say in the mechanical power? This is my electrical energy. This electrical energy converted into the mechanical energy. That mechanical energy basically rotate this shaft. Can you say that the 100% electrical energy is converted into the mechanical energy? That 100% our electric power is rotate the 100% of the shaft power, that convert into the 100% shaft power? We cannot say, because there are some losses are there. In the similar way, can we say that whatever the shaft power has, that total power is transferred to the impeller? Can we say it? So actually, electrical power is going into the shaft power. Shaft power is going into the impeller power, and this impeller power goes into the in the fluid. This is basically going into the fluid. So can I say the total shaft power is going into the impeller? No, we cannot say. There are some losses. And similar way, can we say that the impeller power total 100% impeller power goes into the fluid, transferred to the fluid? Total energy, or you can say total power of the impeller is transferred to the fluid? No, we cannot say. There are some losses actually. So if you will see, from electrical power to the fluid received by the fluid is basically there is some difference, because there are some losses in between them. Right? So that's why we define the efficiencies. So efficiency in the centrifugal pump is a centrifugal pump converts the mechanical energy into the hydraulic energy to move the fluid, and in this process some energy is lost. Some energy is basically lost. What are the reasons of the energy lost? Friction, leakage, there are some losses. So that's why define the different type of efficiencies. First is basically your mechanical efficiencies. Right, so we do not bother about the electrical efficiency, because that is not our domain. We are concerned about other efficiencies. So first is basically what shaft power, whatever the shaft power has, how much impeller got the power from it. Right, so this is the mechanical energy transfer from shaft power to the impeller power. शाफ्ट घूम रही है, उसके साथ साथ इंपैलर घूम रहा है, शाफ्ट घूम रही है, उसके साथ साथ इंपैलर घूम रहा है, राइट? इज इट क्लियर टू यू? So this is basically the power at the impeller divided by the power at the shaft, right? So this is basically my mechanical efficiency. So means whatever the power shaft has, how much power it is transferred to the impeller, this ratio is basically the mechanical efficiency. If the power of the shaft is equal to the total, if the 100% power is transferred to the impeller, it means that it is the 100% efficiency. It means it has the 100% efficiency, right? But it is not possible. The impeller power is always less than the shaft power. Is it clear to you? Why? Because there are losses in the bearings, there are losses in the sails or other mechanical parts. There are some losses in it. So this is my mechanical efficiency. Next is what? Impeller power is transferred. Whatever the impeller has the power, that is transferred to the fluid. So that is called basically my hydraulic efficiency. Hydraulic efficiency means the power which has the impeller and how much power this impeller transfer to the fluid. So hydraulic power output is equal to power at the impeller. Is it clear to you guys? So hydraulic power output. So actually whatever the fluid has the power, this is the power we are getting as output. Yes or no? The power is traveling from the electrical to the mechanical, electrical to the shaft power to the impeller power, and that impeller power is transferred to the fluid. So actually we have that output power. I hope that this is clear to you. I hope that this is clear to you guys. So my hydraulic efficiency is hydraulic power output divided by the power at the impeller. So hydraulic power output of the fluid is basically that output power which I'm getting. ठीक है? और जो ये जो difference आया, the difference is due to the losses due to the friction, turbulence, eddies inside the pumps. Now this is important. What is it? What it is? Overall efficiency. Overall efficiency means what the power, what is the power of the shaft and out of which what power I am getting in the fluid. यहां से अगर मैं डायरेक्ट कंपैरिजन करूं, that is defined as the overall efficiency. These are the in between efficiencies. So let's suppose this is my total system in which pump and fluid. This is my pump power, this is shaft power, and this is the power which is you can say absorbed by the fluid. So how much power is transferred to the fluid divided by the shaft power? That is my total efficiency, or you can say overall efficiency. So what is my overall efficiency? Overall efficiency is my hydraulic power output divided by the power shaft, and it is the basically multiplication of the mechanical and the hydraulic efficiency. So what is it? Hydraulic power output. This is the power actually which is delivered by the impeller to the fluid, or the value of it we already calculated. It is the P is equal to WQH. So this is a very very important formula. आप यहाँ पे ध्यान रखेंगे, यहाँ पे आप इसको ध्यान रखेंगे. Is it clear to you? So this is my power output divided by this is the power input. Power to the shaft, it means it is the power input, is equal to overall efficiency. So here my power output is equal to overall efficiency of the pump multiplied by the power input. This is the very very important, right? So for the centrifugal pump we are using this hydraulic power formula. If you are getting my point, you can tell me. If you are not getting my point, you can ask, guys. You can ask that you are getting my point or not. Right? What is this H? H is the same. That is the total head. This is the total head, or you can say that is the manometric head, or you can say the total head. This is my total head value. You have to add the total heads. Every head you have to take. that in the suction pipe it is my HS, HFS, or in the delivery section it is HD, HFD, or if there is a kinetic then HV, VD square over 2G also, and everything. If you are getting my point, then tell me, otherwise I'm going forward. Let me know, guys. Let me know that it's clear to you or not. So this is actually the important thing. हाँ जी, कौन कौन है? महीना, आर यू देयर बेटा? आर यू देयर? आर यू देयर? और कौन कौन है विष्णु के अलावा? अभी कोई और भी क्लास है क्या आफ्टर दिस? यस मीना, सो आर यू गेटिंग माई पॉइंट और नॉट बेटा? मुझे ऑनलाइन तो काफी दिख रहे हैं. आर यू गेटिंग माई पॉइंट और नॉट? आर यू गेटिंग माई पॉइंट और नॉट, राइट? ओके. Okay, so this is basically total head. You can say this is a total head required, or you can say this is a total head has to be developed by the pump. This is the actually total head, you can see, and this total head is required by the pump. This much head has to be developed by the pump. In that case, only pump can able to lift up the water. In that case, only the pump can able to do our work. Is it clear to you? समझ में आ गई बात? ठीक है. Clear? Okay. Now, fourth one is the volumetric efficiency. Volumetric efficiency is nothing but it is due to the find out the leakage, that how much discharge is coming through the pipe and how much discharge I'm getting. If there is any difference in it, it means there is a leakage. ठीक है. So volumetric efficiency is the actual flow rate delivered by the pump to the theoretical flow rate that pump should deliver based on its geometry and speed without considering internal leakage. So this is my volumetric efficiency. Q actual divided by Q theoretical. That's it, nothing else. ठीक है. Okay. Next thing is, in the case of pump, how we you can say the how we define the Bernoulli equation, or how we write the Bernoulli equation. I think in the Bernoulli chapter I already told you, but here let's understand it. So let's suppose I'm applying the Bernoulli equation at the suction point at the delivery point, right? Okay. This is my suction point, let's suppose, and this is my delivery point, right? So let's suppose this is my suction, this is my reference line, and चलिए आप कीजिए ऐसे कि डायग्राम थोड़ा गलत बन गया. Okay, so let's suppose this is my reference line, and let's suppose this is my point 1 and this is my point 2, right? From reference lines it is Z1, and from reference lines it is my Z2. So how I write the Bernoulli equation in the pump? Simply it is P1 divided by rho g plus V1 square over 2g plus Z1 plus the head developed by the pump. This is the head developed by the pump. Okay, what is it? It is same as capital H. It is a head developed by the pump. And what head pump has to be has to be developed? That total capital H. In that case only it can lift up the water. Is equal to P2 over rho g plus V2 square over 2g plus Z2 plus whatever other losses are there like friction losses and all that. So this is the equation, this is the Bernoulli equation in the pump. In the pump, right? Head developed by the pump is same as the capital H. Don't confuse in it. Don't confuse in it, right? So very simple. If you are, if both the tanks are open to atmosphere, in that case P1 over rho g, P2 over rho g, that will cancel out to each other. That will cancel out to each other, right? Is it clear to you? In that case, just there is no need to apply the Bernoulli equation. Okay, that capital H, you will calculate that capital H value, whatever we have the formulas, and just put in the power formula if is there any question based on the power, right? If there is tanks pressurized, agar tank pressurized hai, in that case you can apply this formula. Okay, in that case you can apply this formula if tanks are pressurized. If tanks are not pressurized, then no need to apply the Bernoulli equation. Okay, is it clear to you? चलिए एक क्वेश्चन लेते हैं. After that question, I think there will be no confusion. So this is the GATE, I think 2015 problem. This is the GATE 2015 problem. And guys, GATE 2015 is the, you can say, I think toughest paper in the GATE history. That is made by the IIT कानपुर. ठीक है, तो 15 में क्वेश्चन जरूर निकालना. चलिए, now let's try to understand, let's try to calculate this question. Very easy question. ठीक है, क्वेश्चन को समझेंगे पहले. And this is the last question of today's class. ठीक है, a centrifugal form delivers a water at the rate of 0.22, means we have the discharge from a reservoir at a ground level to the another reservoir at a height of h through a vertical pipe of 0.2 meter diameter. Through a vertical pipe diameter, and there is no horizontal kind of pipe here. Both the reservoirs are open to atmosphere, so both the reservoirs are open to atmosphere. Power input to the pump, it means this is the shaft power actually. Power input to the pump is 90 kilowatt and it operates with efficiency 75%. It means we have the overall efficiency and we have the shaft power actually. Fanning friction is there. Fanning friction is there, it means we have to consider the friction head loss. And he says that neglect other head losses. Whatever the other losses have, you have to neglect. You have to consider only the friction losses. Take G value is this, density of this. Now the height H in meters to which the water can be delivered. So this capital H we have to calculate, right? Okay. So just we'll try to make the diagram first. So very simple. This is my only vertical pipe is there. So this is my ground level. This is the pipe in the suction point, and this is my delivery pipe. This is my delivery pipe, right? Okay, this is my delivery pipe, right? What is the discharge here? Q is equal to 0.22, and what is this height? This vertical height is capital H. ठीक है? This vertical height is capital H. Diameter of the pipe is 0.2 meter. ठीक है? Both the reservoir are open to atmosphere. Power input P in is my 90 into 10 raised to power 3 watt. And what is the efficiency? Efficiency is my 75%, means 0.75. So we have to calculate this capital H actually. There is no issue. See, first of all, calculate the total head. Total head. What is the total head? Total head is it is given in the question that you have to neglect all the other losses, any minor losses, any kinetic losses, any pressure losses. You have to, वैसे भी open to atmosphere there will be no pressure losses, so you have to neglect the other losses. So just add actually the whatever we have the losses. So first is the friction loss, plus another loss is the height of this vertical height of this suction pipe plus vertical height of this delivery pipe, which is my capital H, and we have to calculate the value of capital H. So what is the capital H value? Capital H is equal to total head minus the friction head loss. I hope that this is clear to you, right? So we have to neglect other losses, so just take the whatever losses are here, ठीक है. सो एक होगा लेंथ वाला, वर्टिकल लेंथ वाला लॉस है ना, एक होगा आपका फ्रिक्शन हेड लॉस होगा. इज इट क्लियर टू यू? बाकी काइनेटिक लॉसेस, एंट्री लॉसेस, एग्जिट लॉसेस वी हैव टू नेग्लेक्ट इट. Very simple. Now if we have the value of HF, let's try to calculate the value of HF. If we have the Q, then use the formula discharge wala. Tell me the discharge wala formula, guys. Head loss FLQ square divided by फलाना ढिमकाना था. Tell me what is that formula? What is that formula? Tell me, guys. I don't remember. जल्दी बताओ. Yes, Maina. बोलिए. कोई बताएगा कि नहीं बताएगा? फॉर्मूलाज ध्यान रखो भाई, ठीक है. फॉर्मूलाज ध्यान रखो. इट इज माई कैपिटल एफ एल क्यू स्क्वायर डिवाइड बाई 3d5. याद रखो, ऐसे नहीं चलेगा, ठीक है. बहुत काफी टाइम बताया, बाद में बताया. सो दिस इज माई हेड लॉस. नाउ व्हाट अबाउट द टोटल हेड लॉस? व्हाट अबाउट द टोटल हेड एक्चुअली? What about the total head actually? So I know that my overall efficiency is my power output divided by power input. So my power output is basically overall efficiency multiplied by the input power. What is the output power? Output power is my WQH is equal to, what is H? It is my total head, right? Which I already told you. This is my efficiency, overall efficiency multiplied by input power. What is my total head? Efficiency is my 0.75 multiplied by input power, that is 90 into 10 raised to power 3 divided by W. W is my specific weight, which means rho into G. W is what? Specific weight, rho into G. Rho is my 1000 and G is my 9.81. So rho G is basically 9810. Multiply by discharge. Multiply by the discharge. We have the discharge, that is 0.22. You have to calculate the value of HT here. You have to calculate the value of HT here. क्या है HT की वैल्यू? तो what is the value of total head here? कोई कर सकता है कैलकुलेट जल्दी से? Can anybody calculate this value, guys? Anybody? या मैं ही करूँ? It is my 0.75 multiplied by 90 divided by 10 is power 3, 10 is power 3 cancel out to each other. 9.81 multiplied by 0.22. It is my 31.27 meter. This is my total head loss. Now calculate the HF value. HF is my capital F. So we have the value of small f. So capital F is 4F. L, and it is my Q square divided by 3d5, right? So we have everything. You can calculate the value of HF here, right? So L is what? L is my vertical height. Vertical height is my H itself. So HF value is 4 multiplied by small f value. What is the value of small f? What is the value of small f? 0.004. L is what? It is my h. Q square is 0.22 square divided by 3 multiplied by diameter. What is the diameter, guys? What is the diameter given to you? It is 0.2. So it is 0.2 raised to power 5. Right? So this equation is in the h actually. Right? So put this value here. So we have the HD value and we have the HF value. This is in terms of h. This value goes here and it is plus terms of h. Now you can calculate the value of h. I hope you understood the thing, what I'm trying to say. Right? H is equal to HT means 31.27 minus whatever this constant is. This constant, let's suppose it is K times H, and this is actually H into 1 plus K is equal to 31.27. ठीक है, यहाँ से आप H निकाल लेंगे, क्या आएगा आपका H? Clear? Is it clear to you? It is small f? No, I think it is not small f, it is capital F. Vishnu, it is capital F, I think. Mahina, confirm it is capital or small? As I remember, it is capital F. अच्छा, पक्का? आर यू श्योर? एक बार मुझे भेजना, नोट्स की फोटो भेजना एक बार मुझे.
नहीं बेटा,
अच्छा, चलिए मैं भी कंफर्म कर देता हूं. ये तो पहले आप मुझे बताइए कि जो हमने अभी पढ़ा, दैट इज क्लियर टू योर नॉट? दैट इज क्लियर टू योर नॉट? ये बता दी मुझे बस. बोलिए. ठीक है, अच्छा बस डाउट क्लियर कर दूं। अभी मैं डाउट क्लियर करने के लिए बैठा हूँ, टेंशन क्यों ले रहे हो आप? हम्म? टेंशन क्यों ले रहे हो? मैं डाउट क्लियर करने के लिए ही बैठा हूँ यहाँ पे। मुझे ऐसा ध्यान आ रहा है कि दैट इज कैपिटल एफ लिखवाया हूं मैंने। एक्चुअली दिस इज कैपिटल एफ, ठीक है। एक बार कंफर्म भी करना पड़ेगा इसको। जहां तक मुझे ध्यान आ रहा है दैट इज इन द कैपिटल एफ एक्चुअली। चलिए करता हूं मैं कंफर्म इसको, ठीक है, मैं कंफर्म करता हूं। चलिए तो काफी टाइम ले लिया आज मैंने। पहले ये बताइए कि यहाँ तक क्लियर है सबको? ये फॉर्मूला एक बार मैं कंफर्म कर देता हूँ आपको आफ्टर क्लास, ठीक है। यहाँ तक क्लियर है हाउ वी कैलकुलेट द क्वेश्चन, how we calculate the question and how these things are important, how we decide the head loss, how we decide the things. So is it clear to you? यहाँ तक क्लियर है आपको? यहाँ तक क्लियर है? टेल मी। ठीक है, चलिए इसको मैं अभी कन्वर्ट करके आफ्टर द क्लास मैं इसको अभी देखता हूँ कैसे मैंने ये लिखवाया है, या मैं कुछ मिस्टेकनली कुछ दिमाग में गलत घुस गया है, क्योंकि मुझे ध्यान आ रहा है कैपिटल एफ होगा, या हो सकता है नीचे कुछ अलग टर्म हो। लेट्स डिस्कस इट, मैं डिस्कस करूंगा अभी, मैं भेज दूंगा आफ्टर क्लास इसको कन्वर्ट करके कैसे क्या है देख लेंगे, कोई बहुत बड़ी बात नहीं है। Sir, we apply the Bernoulli equation, then we will get the same final equation. Yes, Bernoulli equation आप अप्लाई कर लीजिए, कोई इशू वाली बात नहीं है उसके अंदर। There is no issue in the Bernoulli equation because it is open to atmosphere. It is open to atmosphere, तो कोई प्रॉब्लम ही नहीं आएगी आपको, वैसे ही प्रेशर वाली टर्म्स जीरो हो जाएंगी आपकी। But again, I'm saying there is no need to apply the Bernoulli equation. Bernoulli equation को आप यूज ना करें, ठीक है। You will get the same answer, there is no issue, but that will be the lengthy process. Because I know that I have to neglect other losses, then why I will take unnecessarily write the Bernoulli equation in terms of P and V. समझ रहे मेरी बात में क्या कह रहा हूँ? समझ रहे मैं क्या कह रहा हूँ? So there is no need to calculate it. There is no need to calculate. इसको कैलकुलेट करने की, अलग से कैलकुलेट करने की कोई आवश्यकता नहीं है। बर्नौली लगाने की आपको कोई आवश्यकता वाली बात नहीं है इसके अंदर, ठीक है। अननेसेसरी आप उसके अंदर जो है वो टर्म्स डालेंगे फालतू में, कोई मतलब नहीं है। टर्म्स डालेंगे फालतू में, कोई मतलब नहीं है, नहीं, ठीक है। बट यस, इफ यू अप्लाई द बर्नौली देन आंसर तो आएगा ही। आंसर क्यों नहीं आएगा, है ना? आंसर तो आएगा ही, क्यों नहीं आएगा आंसर, ठीक है। ओके चलिए फिर मिलते हैं नेक्स्ट क्लास में, ठीक है। अभी आपका एक लास्ट टॉपिक बच गया, दैट इज लास्ट टॉपिक ये एक पंप का टॉपिक है, एनपीएसएच, नेट पॉजिटिव सक्शन हेड। एंड एक टॉपिक जो इंटरव्यू प्रोस्पेक्टिव से थोड़ा सा रहता है इंपॉर्टेंट, दैट इज अ कैरेक्टरिस्टिक कर्व, pump characteristic curves. That topic, two topics plus some questions we will discuss in last class. So the next class will be the last class of fluid mechanics. Next class will be the last class of your fluid mechanics, right? चलिए ठीक है, चलो फिर मिलते हैं नेक्स्ट क्लास में। थैंक यू सो मच, बाय बाय एंड टेक केयर। मिलते हैं नेक्स्ट क्लास में, चलिए ठीक है, ओके। कुछ डाउट्स हो, कोई क्वेश्चंस के, तो आप भेज देना। पढ़िए इसको, आज का जो हमने पढ़ा है दैट विल बी बेसिकली मोर कंफ्यूजिंग, इसको पढ़े अच्छे से। इफ यू हैव एनी डाउट शेयर योर डाउट्स इन द टेलीग्राम, और नेक्स्ट क्लास में से पूछना फिर, ठीक है। चलिए बाय बाय, टेक केयर गाइस।